Good morning, and welcome. Welcome to Portland and to PuppetConf. I'm really happy to have the conference back, to have all of you back for the first time since 2011. The very first PuppetConf was held here in 2011, and it's great to be back in town. I do think of Portland as my home. This is the second time that I've lived here, and it's a great city to be in. I love the food, I love the coffee, I love the drinks, I love that I get to ride my bike to work. It really is a city that I like, that you get to live in and not just live near, which I think is a very nice situation. And one of the reasons I like living in Portland, I like being in Portland and having the company in Portland, is it gives you a great amount of space and incentive to do work. There's a good combination of enough pressure that you have to do well, but not so much pressure that you have to do well tomorrow, which I think is an important difference. It would be a little bit ludicrous to talk about all that's happened since 2011. All the numbers would be like 10,000%. So just looking at the last year, it's been a really great year in the Puppet world. We've got more than 30,000 companies that are using Puppet in some way, that are involved in the ecosystem using the technology. And 22 companies a day start using it for the first time, which really goes to show the health of the ecosystem and the growth and really the value of the technology. We also have more than 3,500 modules on the Forge. These are modules mostly that all of you have written and are responsible for maintaining, and they're modules that everyone in this community relies on to do their work, to get their work done. And these modules are obviously a critical part of what makes Puppet valuable. If you had to start from scratch with every single thing that you did, that's not nearly so valuable. We at Puppet Labs have almost 1,000 paying customers for Puppet Enterprise. And while not all of you might care about that, it actually is pretty important to have the ability to build a healthy business around this healthy ecosystem so we can keep supporting all the developers, all the training programs, all the great events like this. And Puppet Labs itself has almost 400 employees. It might actually have 400 this week. It's going to cross one of these weeks. And one of the great things about having PuppetConf here in Portland is that a huge portion of those employees get to visit. We don't have to send buses and buses of people down to San Francisco or horrible Las Vegas, for example. And that makes the event better for you because you get to meet all the people who are responsible for making the company such a great place to work and see all the work we do. Last year at PuppetConf, I talked about how far we've come. Because if you look back 10 years ago, when I started Puppet Labs, there were a couple of big reasons why I started the company, but two stand out in retrospect. And one was, it really looked like there were all these great ideas, but no one was gonna build any companies around those great ideas. So I hung out with a lot of people who were building interesting technologies, but no one was saying, I'm gonna bet my career, or I'm gonna spend every waking moment for the next 5 years trying to make everyone in the world use this technology. And it also seemed strange that there weren't really any sysadmin entrepreneurs. Everywhere I looked, it was all developers, it was all business people. What a horrible idea, business people starting companies. And people in the world that I understood, in the world that I knew, they weren't out starting companies trying to go build interesting new things. And if you just look back in that 10 years, we've obviously come a long way. There are a bunch of companies now run by sysadmins, or at least founded by sysadmins. And unquestionably, there are a ton of really interesting new technologies in our space that are driven by people trying to get everyone to adopt it, right? It's not an academic pursuit anymore. It's something where people have realized, wow, if we invest in operations, if we invest in the tooling that makes it necessary and possible, that makes it possible at least, it was already necessary, to maintain your infrastructure, it really makes a very big difference. And last year I claimed that we were at step 2 out of 20, that we had a long distance to go before we got to that destination, right? We've come a long way, but not compared to how much further we have to go. And I've been thinking for the last year, how do we talk about what it is that we're trying to get to? How do we talk about that place, and how do we talk about the work we're doing in a way that isn't too tied to one individual technology or one individual role? And the best phrase I can come up with is that we're working on the software supply chain. And obviously there's no specific definition of this, right? We could all have a very long and unproductive committee meeting about what exactly this does or doesn't mean. But I think of it as everything that's necessary to procure, install, manage, turn off all the software that you use. This obviously means all the software vendors themselves, right? If you are using, Oracle, or WebSphere, that's clearly part of your software supply chain. But it's also all of the open source libraries that you use. It's all of the operating systems. It's all of the services you use, like Amazon Web Services and Fastly. It's the hardware providers, EMC, Cisco. Every single component of providing a service to your customers is going through some sort of transformation. I'm sure you all saw the rumors yesterday about EMC and Dell merging. That's not because things are going really, really well and nothing's changing for them. It's because the world is going through tumultuous changes right now. And those changes are all about changes in how we build, deliver, and manage software. The problem right now is the majority of our software world, the majority of how we think about software, is too artisanal. It's part of why we brought it back to Portland. It really just makes sense. It's too bespoke. There's too much creativity. There's too much variety in what we do. If you go take a given problem and go to 10, 20, 30 companies and assess how they solve that problem, you're probably going to see, well, frankly, if they're big companies, you're going to see hundreds of different solutions because it's not even consistent across an organization. It's inconsistent from department to department. And some of that variety is important, right? Some of that variety is, well, we had good reasons to be different. But the majority of that variety is pretty much arbitrary. It's there because somebody had a different set of experiences. Somebody was reading a different website that day. Somebody went to a different school and therefore was influenced by different technology. I went to Reed College here, and so I grew up using Macs. You might have grown up using something different, and therefore you do things differently. It's not that one of us is right or wrong. It's just, it's different. And some of that difference adds value, but most of it, not so much. We need to move to a world that's more manufacturing-like and really is anti-craft. I love the opportunities for creativity in crafting things, but the counterpoint to that is a lot of that creativity should be further up the chain. It should be further away from the implementation. And if we moved away from this artisan operations world, we could have more consistency. We could have much greater amounts of reuse because, hey, if you solve the problem, I could always reuse your solution to that problem. We would have greater reliability, and fundamentally, we would have greater speed and greater throughput. Because it's not just about speed of doing one thing one time. It's about how often you can do that. When you're looking at software, especially today, we all know that we need to move away from that deploying software every 3 quarters or once a year and deploying more often. But the reason for that, the reason why, and that's of course increasing throughput, right? The reason for that is we need to build learning, adaptive software supply chains. We need to build systems that learn more quickly. The products we build need to change quickly in response to the customer. This change will happen. At some point in the future, you'll look up, and the way that we build software, the way that we manage software, will look like this. It will be adaptive. It will be a quickly evolving system. It's not going to happen right away. I don't know whether it's going to be, I know it's going to be more than 5 years, probably even more than 50 years, but it definitely will happen. To get there, we need a lot of changes. Today, most of IT is built, well, it's really built around bits of tin. Individuals in IT are responsible for, well, I'm the person who handles the spinning Rust, and I'm the person who handles the box with all the internet ports on it, and I'm the person who handles the box with all of the hot CPUs in it. Or maybe 1 or 2 levels up. I'm the person who handles all of the databases, and I'm the person who handles this specific variant of operating systems, and I'm the person who hates that other person but handles a different variant of operating system. And everyone's kind of looking for their own bridge to live under. But we have to shift, because in that world of specialties, in that world of individual technical focus, what we lose is what matters to the customer. We lose the customer value that we're delivering and our ability to shift our role, to evolve our role based on that customer. Earlier this year, you probably saw us publish the DevOps report. This is a report that we built based on more than 5,000 surveys. Well, one survey, 5,000 times. Very repetitive. And DevOps is all about culture. DevOps is all about these organizational shifts. And one of the things we were able to assess in this DevOps report was to what extent this shift has already happened, to what extent it's happening right now, or maybe it's already done, maybe it's complete, who knows, right? And the DevOps overall is really about what I was just talking about, aligning the goals of operations with the goals of the business, aligning operations with the value of the customer, the value that the user gets from the work that you do. And the DevOps report found a lot of great things. Things like people are, let's see, I'm going to try to remember the numbers from memory, but 65 times more frequent deployments, things like that. There are far less failures, more frequent deployment, greater reliability, things like that. It's a great experience. But one of the big things the DevOps report showed was it's still mostly a theory. In the same way that people's private cloud strategy from 5 years ago became, let's rename our vSphere infrastructure to a private cloud, a lot of people, their DevOps strategy has been, let's rename our sysadmins to DevOps engineers. And that's not an entirely bad idea, because at least it makes it clear, hey, you need to be in this new world. And when you look at the recruiting profiles for sysadmins versus DevOps engineers, they are different profiles. So there is a cultural change driven through this kind of work. But it's still pretty theoretical. And this idea of aligning all the work that we do around the customer experience, around the customer value, it's a strange idea, and it takes a really long time for how our organizations are built to restructure. One of the major differences between the Japanese car companies and the American car companies, especially in the 80s and 90s, was the American car companies had this perspective that you design in quality, and then at the end you figure out, did you achieve quality, and if not, you go try to fix it. And everyone knows about the end-on chords in the Japanese world, where if you discover a quality problem, you stop the line right then, and you don't fix the quality problem. You don't fix the car that has a problem. You fix the process that led to the car having a problem. You can't add quality in at the end. You have to build the entire system with that quality in mind. Very similarly, you can't add a great customer experience onto the product after you've built it. You can't add a great customer experience onto any of the technology that you're building. The evolution of your organization has to evolve backwards from the customer. The choices you make in terms of tools, in terms of process, in terms of technology, all of that has to evolve backwards. And tool choice in the end needs to be about enabling software improvement. This picture here is one of my favorite tools. If you look on the car doors, some of those doors have little white cards on them. Those are Kanban cards. And Kanban cards were a really great improvement to how to manage inventory in building a car. One of the big problems you think about, I've got a factory and I'm assembling doors. One of the big effects on how quickly you can assemble cars is, do I have enough doors but not too many doors? If you have too many doors, then you have to step around them and you can't actually do anything. But you have not enough doors and you sit there waiting for doors. Well, they built this ridiculously simple process that says, hey, when you have not quite enough doors yet, you take one of these cards and you hand it to somebody and they bring you more doors. It's ridiculously simple, but they found it allowed them to significantly optimize the entire chain. And relatively quickly, apparently, they actually abandoned this practice because they found another way of doing the same thing. Because again, what they were focused on was optimizing the entire car supply, the entire throughput of the system, not, wow, I really like Kanban cards. I'm a Kanban card system. I'm a Kanban card person, and so we have to stick with that. That's not how they thought about the world. You know where this future is, right? You know what that future looks like, where everything is more automated. You know that we have to move away from the individual bits of technology, and we have to add everywhere we can these incremental pieces of automation, right? Every place we can add an additional automated step gets us closer to that future world. Every time we can move away from these manual handoffs and Jira tickets as a means of moving work down the pipeline, when we can move away from that, we get more into this automated world. If we can move instead towards APIs and software negotiation of these handoffs, we get closer. And one of the great things about each of these incremental investments is that they both move us closer to this world we want to be in, this world where all software isn't crap. And but in addition, each individual benefit, each individual step brings real benefits on its own. Right? So you've taken 5 minutes out of somebody's life that was wasted waiting for a ticket, or 4 hours in lots of cases. So it's this great combination of step by step, we make the world a little bit better and also get closer to where we want to be in the long term. We at Puppet Labs are here to help you get there. We as a company are all about reducing the timeline from the moment you get new technology to the moment it's in the hands of your users, delivering real value. We started with Puppet because, in my world, in the world that I lived in, that was the major difference. That was the major barrier to people delivering software. But you're going to see us as a company evolve over time to get better and better at aligning the tools we provide, the work we do, and the work that we enable with helping you more directly, more consistently, and more repeatably delivering customer value. You've already seen that we've announced the new Puppet Application Orchestrator. This is a really substantial step forward for us towards that goal. It's a critical link connecting all of the components of the software supply chain with the value that they deliver, allowing you to express all of the pieces necessary to deliver an application in one unit, manage it as that unit, manage it as an application, deliver it as an application, audit it as an application. And it's part of a unified stack that is going to help us be the standard for the software supply chain. The people in this room, the people watching on the audience on the internets right now, all of you have an unfair advantage. The Forge that exists right now, the 35 modules, 100 modules on the Forge, all work directly in this new orchestrator. So that means the work you're doing today, and that's the 3,500 modules in the Forge, plus the thousands and thousands that you've written internally that you use and haven't published. All of these work in the orchestrator right now. The orchestrator also relies on the exact same declarative model-based approach that has helped Puppet be so successful, that has helped you be so successful. So all the tools that you're already used to, they work in this new world. They work in this world of, I can now talk about more than just the infrastructure. I can talk about distributed applications. And that's going to help you. And because no one lets me touch code anymore, I'd like to introduce Ryan Coleman, who's going to give you a demo of the product and talk in more detail about it.
Hi, everybody. Wow. Look at all of you. Good morning. I'm excited to be here and honored to have the chance to talk to you about the Application Orchestrator. But first, I want to address just how surreal this is for me to be here talking to all of you. 4 years ago, as a redneck sysadmin from a university in central Pennsylvania, I came down the street to the Winningstad Theater for the first Puppet Conf in 2011 here in Portland. And it was just an amazing experience for me because I had been tasked at Penn State a university in Pennsylvania. I had been tasked to migrate a bunch of departments' exchange services to VMware's Zimbra product. If anybody here has used Zimbra, you'll know that's a tough order. And not only was I responsible for managing that service and getting everybody migrated, I had to work with one other sysadmin to spin up all those machines, and I just couldn't do it. We couldn't get that much infrastructure in place without something like Puppet. And so I came out here to kind of feed off of that excitement, the freedom that tool gave me and how it helped me save my job in a lot of ways. And so what really struck me about this was just the space in Portland, the community here. It was just a lovely space. And I looked up this stat last night. At this event, we had 400 attendees, as many employees as Puppet Labs has now. The scale of that is incredible. It's mind-blowing to me. And so not only was it this cool space, it was my first time to Portland. We had donuts from this place called Voodoo. There's just a lot of fun talks going on. But what really stuck with me was the community that I met there. These were all these sysadmins who were sharing the story that I had to share about how Puppet changed my life. And I got to meet all these Puppet Labs employees that were just giving me this adrenaline rush of excitement. Like Nan Liu, who, when I ended up joining Puppet Labs as a professional services engineer, mentored me on how to be a traveling sysadmin, helping people share that enthusiasm and teach others how to use Puppet. Just what wonderful people, all excited about automation. And I got to watch Luke give a keynote. He likes to make up some words, but he also gave a speech that just made me excited and proud to be a sysadmin. It was not something I had seen in the conference circuit for higher ed. It's not something I saw at the conferences for VMware or other big vendors. It was something unique to me at the time. And it made me so excited that I did just shortly after join Puppet Labs, and I haven't looked back since. But it was also a sign of things to come, and I hadn't quite realized that, how many people would influence my life there and how it would impact the last 4 years here at the company. For instance, Eric Sorensen here on the left side of the screen, he was also a sysadmin coming to the conference just to share his passion for Puppet. And he would later join Puppet Labs. You can see him here negotiating his contract for that pile of shirts. And so I came in as a professional services engineer, but he started right at the time I was transitioning into product management. And he and I started about the same day. I was on Forge, he was on Platform. And we went through that trial by fire together. Like, what does it mean to be a sysadmin turning into a product manager at a small startup? I think we were about 60 people, maybe a little more. He taught me how to be a better product manager. Most importantly, Eric, I don't know where you are now, but you taught me how to be a better human being. You're the best. Thank you. You're one of those special people. Also, I didn't realize then that I would meet all these people I got to work with on the orchestrator I'm about to talk to you about. For instance, here I am sneaking up on Nick Lewis, one of the main engineers on the project, who was talking to Deepak, I think at the time, about PuppetDB that they were about to write, making some joke about Grayskull or He-Man. And also, I got to meet, or at least I got to see a talk from, I didn't meet him at the time, but David Ludercourt. I hope you've used the tool he wrote, Augius, which is a configuration automation tool. And that was a huge tool in my toolbox. And in a lot of ways, it was my gateway drug to Puppet. And so I was really excited to kind of see David there. And obviously, I didn't know at the time. He was here. He wasn't at Puppet Labs. He was with some company that makes specialized hats. And he was talking about cloud automation. And if you notice, he was working on the orchestrator. So it's really kind of fitting that he's the lead engineer on the project here for the product I'm going to talk about. So let's get to that. So Puppet Enterprise has always been about helping you automate core infrastructure, application infrastructure, even application releases. We use Puppet today to manage our Puppet Forge, and I'm going to talk to you more about that. And across all of these different verticals, you can get a lot done with Puppet. And for me, yeah, I guess I'll tell you a story here, because I have a buddy who just came in from that university, and we were reminiscing about some of the infrastructure I used to maintain. In addition to this Zimber project, I was responsible for a lot of the core infrastructure for the university, the file services, mail services, and one of them was Shibboleth. Any Shibboleth fans in the room? Internet 2, what up? Okay, a couple of you. But Shibboleth was, it was an interesting project for me to work on, because and so I guess I should explain it since there are only 2 people in the room. It's a federated identity service. So institutions like that university in Pennsylvania might say, hey, these students from another university can come and access our library system. They can come and access our learning management system. But they're going to do that with the accounts they have at their home university. And so Shibboleth's a way of doing some federated authentication. And what was cool about that is that I got to work with a network admin who was the classic, well, he wasn't bearded, but he was kind of the neckbeard network guy who would always be manually doing it. He would never automate his network. But he was also responsible for Shibboleth, and he was a big Internet 2 guy. But he was a bit of a Luddite in the way that he didn't have a phone. Even when the iPhone started to come out, he had a paper cutout of an iPhone, and that's where you could send him text messages. It was on his door. He had like a regular phone that you put up to your ear, and that's how he would talk to people about whatever identity he was adding into the system. And he had a workstation that was like, I think it was HP-UX, like an HP 9000 or something. It was just this ancient thing he used to shell into the infrastructure he managed. So just to give you a sense of, this guy's not going to get Puppet. He's not going to go in and write Puppet code. He's not going to manage Shibboleth. But I wanted to make it easy for him. And one of the things that really excited me about Puppet was that I could give this guy, who would just manually tweak these XML files for Shibboleth, I could give this guy a tool that he could use to just edit his configuration file, save it to our distributed storage system, our GPFS file system, and that's all he needed to do. From that point, he just ran a command that I built for him that ran Puppet with a specific tag for just that Shibboleth configuration. And it would validate his config, it would give him some feedback, it would deploy it to all the nodes. He loved it. He was so ecstatic by this because he went through, we shibboleth these multiple nodes all in a cluster, and he would spend an entire day just adding a university to the system as he's handwriting every file and he's shipping it, and he's all stressed out because everything's got to be just so, and the system's down. And with Puppet, he just did it. And what I was talking to my buddy about was after I left the university, they took out Puppet and replaced it with another vendor's configuration management tool because that's what they knew and they didn't want to invest in Puppet. Okay, hurt my feelings. But what I learned last night is that apparently they ripped it out for shibboleth, and the first thing that they did was take down the production infrastructure during admissions week. And so they immediately went back to manually editing their servers. It's just, I'm hoping to go back and convince them that Puppet was the way to do this. But enough about that. So I want to talk to you, before I get to the application orchestrator, I want to talk to you a bit about a couple of the qualities that make Puppet so special. And these are qualities of Puppet for managing node-level configuration that we're going to elevate up to application infrastructure and the application releases that you care about. So the first is composition. The Puppet DSL is great at letting you focus on a particular task. And for me, that was just the task that I needed to do every time I provision a machine. So it was getting SSH configured, it was getting the LDAP and Kerberos infrastructure in place, all the core configuration I needed so that a machine could go and do whatever it is it was going to do. And I started there, I found success there, saved time there, and moved on to problems like shibboleth. And so I hope you have that story as well, whether it's the thing burning down around you or just the menial tasks you do every day. And what was so great about Puppet is just that you could compose those configurations into as granular or as broad as you wanted, and then you could combine them all together to represent an individual node and reuse those configurations across different nodes with different sets of needs. And so with those composed configurations, you got to be flexible in how those configurations were enforced on an individual host. Using Factor, you can make tactical adjustments if the IP address changes. You can make accommodations based on the operating system. And with all the facts available or the custom ones you've written, you could get as granular as certain BIOS needs certain driver, so I'm going to insert that on a particular configuration. And so that's kind of tactical flexibility, but it's also strategic. If you have all those compositions ready, you can migrate from one operating system to another. You can build a new data center from scratch using the same configuration and then just migrate your data. Or you can move from public to private cloud or back and forth. So Puppet's also about predictability. And primarily that's the no-op mode. And that's what I gave Max at the university. He got a command to run and say, what's going to happen across my shibboleth fleet? And then he could run another command that would enforce that configuration. And when he did that, he knew for each server, for each resource, his config file, the services itself, the Terracotta memory share, he got information about how that deployment was going to go. And that's what excited him most, I think. He got not only just this simple one-click button, he saved a file, hit a button, but he also got a lot of confidence that it's going to go well. He didn't have that stress anymore. And so whether you're doing a single node or every node in your data center, that ability to simulate what's going to happen at a resource level or an entire system level is really important. And finally, Puppet's been about orchestration. And that's sort of in how it does its job. It has a lot of tasks that it does to do anything you want to do. But orchestration is primarily about those relationships. You get to focus on the relationships that matter between resources in the common package file service pattern. You're managing, you get a package in place at a desired state, then the configuration file that you want to build on top of that. You set a relationship between those two. And then the service that package is installing for you can respond to changes in that configuration. Anytime it reconfigures, you restart or rehup or whatever it is. And that ability to let you focus on these relationships matter. And that's within one little set of configuration. Or then later when you say, this configuration relies on that configuration, or you want to respond between classes of configuration. And that's what's so unique about Puppet there is that you're focusing on the things that matter. You don't have to think about the full scale of your infrastructure. But as soon as you do apply a huge set of configuration to an individual node or across all nodes with the orchestrator, Puppet knows about those relationships that matter, and it will take those into account for you, so you don't have to think about them at the broad scale anyway. So primarily today, I'm going to talk about how Puppet's evolving and elevating up the stack to help you manage distributed applications, the things that matter to your business, whatever that business is. And I want to talk about these different categories for a second here. First, core infrastructure. This is the foundation of our success. You're here today because you're excited about doing that, or you used it, or you had a story like mine that really just got work out of your day so that you could focus on making Luddites with an HP UX machine excited. That was huge for me. So whether it's increasing ubiquity, making Puppet run on more platforms, automating things that Puppet can't manage today, like network devices or storage, just interacting with those APIs, all those things you find on the Forge today, over 3,500 of those, you can manage today. And with the orchestrator, you're going to have context at the core level of what service or services is this machine providing to the rest of my data center. And you can use that now to manage core configuration. But it's the application infrastructure that we're really focused on today. And this is classically your middleware tier, your database, your load balancer. But it doesn't have to be. There's a few qualities that, from Puppet's perspective anyway, make it application infrastructure. You have dependencies between systems. So in that middleware stack, you've got a database server and your WebSphere server, let's say. That WebSphere server needs to know, where's my database server? What port do I bind to? What credentials am I providing? What database am I providing those credentials for? And between those systems, that information is being produced or consumed, either implicitly or explicitly. Maybe you're hard filling that in, but the system knows, the database server knows what the database is and how to connect to it, and the application server should be able to get that information. And when you combine these things together, they have to be managed in a particular order. All right? Whether that's run all the time and make sure they're there, or database first, then WebSphere, then your load balancer, or whatnot. The first time, or any routine maintenance. And I want to walk through an example here through the common mobile banking app. And again, application infrastructure could have been your Elasticsearch cluster, it could have been your mail cluster, whatever's important to you, whatever distributed application you have. But when it comes to apps like this, I think it's kind of interesting to think about, because I haven't done any banking that hasn't been on my phone, really, in the last 4 years. In fact, I haven't walked into a bank branch in the last 4 years. After I moved to Portland, whatever, all these hipster banks can just, step off. The 90s are alive. But these are driving a lot of infrastructure creation because they're so simple to use and they just change your behavior. I don't think I've gone to an online banking site in a couple years either, like on a laptop or whatever. But they're deceptively simple. There's a lot going on. And for any individual thing you're doing in that app, it may not be the same infrastructure making that happen. You may, if you got a banking app, it's likely that the whole system behind your money is separate from the system that owns your account, or the system that owns records that aren't under the kind of protections that those other two are. And those infrastructures are connected as well. They've got dependencies, they share information with each other, they need to be managed in a particular order, they're often clustered. And so if you take one piece of that infrastructure and you align it across hosts, you get all those capabilities of composition, that Logstash, the SSH, the Windows remote management, all of that is shared. You can just stamp it in. It makes accommodations based on facts. But then that middleware, that tier there, is not quite connected. Puppet hasn't had the context to do that. You may have done that with exported resources. You may be using mcollective to run in the right way. But that's all just eating around this sense that Puppet doesn't have native context for this. And so what we're really going to talk about here is giving Puppet that native context. And I should have pointed out that with that exported resources and mcollective trick today, you end up still running into a convergence problem where you have to run Puppet over and over again. And we consider that a bug. Puppet was designed with the idea that it's idempotent. You run, you configure, you send a report, you're done. The fact that you've had to run Puppet over and over again is a bug, and we're going to solve that here. And so to do that, we're giving Puppet this sense of how these machines relate, what information they share, and with that information, how they need to be managed in a particular order. And services are the foundation of the orchestrator. And by services, I mean all of these things that are in your data center today. They're absolutely everywhere. And I think of it kind of like gravity in the sense that it is everywhere. It affects everything you do day to day, but you may not think about it that often. I'm guessing you have a spreadsheet of all the services you provide. If you're really good at it, you know which machine in your data center is providing that individual service. But I'll bet you don't have an association of what machines depend on the machine providing that service. It might have gone stale. And it's a spreadsheet in Dropbox. How useful is that for making changes when things are blowing up? And this infrastructure is that, again, that middleware stack I talked about, but it's also any infrastructure that matters to you. If your job is to provide mail for your work group, that's your business. That's your application. You still need to manage it. It's still distributed. It still shares information. Elasticsearch, if you're logging, that's there too. In fact, I got to play with Elasticsearch because of this product and build out clusters and play with the new Kibana. It's kind of fun. So directly or indirectly, these things matter to you. They're everywhere. They produce information. And they make this glue between this infrastructure. So if you take two examples here, that database and HTTP endpoint, that Microsoft SQL Server knows it's producing a database for use. It knows what the port is, what the host is, how to connect to it. And that AIX machine providing WebSphere, it now knows how to connect by way of this service. It knows that it needed that database. It's got that information, and now it knows how to connect. It's got all the credentials it needs. And similarly, if it's offering an HTTP endpoint, that F5 load balancer or whatever you're using needs to consume that. And there's likely many of those HTTPs from many of those WebSphere servers. And it's not just one service per box, right? If you've got a Microsoft SQL Server, I hope you've got more than one database on it. And those just make up multiple applications. These components, that Microsoft SQL Server, that AIX machine, they may be producing multiple services, and that matters too. And as soon as the orchestrator and Puppet have this sense of shared context, now if you go back to that idea of simulation, if you need to do an update on that database server or your load balancer, Puppet knows which applications are affected, what services were involved, what order would I need to manage the whole thing in to do a full update across all the interconnected infrastructure. And so before I jump to a demo of this, I want to walk you through another application that's critical to our business, the Puppet Forge. And it's as surreal as it is to be here 4 years after the first PuppetConf, it's also a little weird not to be giving you a pitch about some new feature of the Forge. But I want to thank you, every one of you who's contributed to the Forge. I think we have over 1,000 contributors now. Some of our modules in the Puppet Labs namespace have over 200 contributors each that aren't Puppet Labs employees. It's been a fantastic product to work with. And what I was doing with this orchestrator is using modules right from the Forge to plug into this distributed application infrastructure without modifying any of them. They all are fantastically written, and I could just plug them in. And so for our Puppet Forge, I had to steal from our operations team as well. They run the application, they run the Puppet Forge with Puppet. And it's not a simple application either. It's got a database. It's got an API service that many community members have written tools against, the blacksmith tooling, for instance. And it's also got the web service that you recognize as the Puppet Forge today. There's a unicorn application server providing that. There's load balancers in play. But in that same way, there are services that matter. And the Puppet code that makes this happen is the Puppet code you already have, that our ops team already had. You may have written them as profiles in the roles and profiles sense. They may just be declarations of classes and resources. But the point is, the work's already been done. You know what these machines individually are doing. And so all we really needed to do for you is give you a sense of context, this service, and give you a way to tie them all together. And so that's this application model. This is the biggest piece of new syntax, and you could tell that for this Puppet Forge, it's not that much. And again, what I'm declaring here, the site PQL, the API, the web, these are like my profiles. Inside, I'm just declaring some Puppet code to make a Postgres server, for instance. I pass data into them. This new application construct behaves like a defined resource type in how it's defined. You could pass name through and use that. The instance of the application can be the name of the instance of your components. And you'll notice we have new metaparameters here, export and consume. And that's really the key here. We're talking about the services that matter to these things. We're not expressing relationships directly between these components because you may want to swap them out. You may switch which Postgres module you're using to configure that machine. You may rewrite it. You may do a refactoring. You may go to an entirely new version. But from the API's perspective, nothing changed. I need SQL, I need to know where to get it, I need to know what port it's on. That's all it cares about. It doesn't care about the implementation details. So instead, you're relating by way of these services. The PQL exports SQLs, the API consumes them. It's also making HTTP endpoints that the web service uses. The web service is consuming that and producing its own HTTP endpoints that the load balancer uses. So I'd like to give you a quick look here. Great. Also, if you haven't gone and looked at Pluto or water on Mars, I didn't plan this, the theme of this conference, but I am so glad that space is in the news. So what I have here is that manifest I just showed you, the Puppet Forge. I'm going to show you two examples here. One is a little more complicated, this one just to get the concept across. And on the right side here, I have a Puppet Enterprise machine built with the orchestrator. But first, I want to walk you through a couple of these concepts. So again, these are just profiles. If I take a look at the PQL here, I'm just passing in some information. It's got some declarations in it. There's nothing fancy. It exports these SQLs, consumes SQLs. The API exports those HTTPs. What does that look like? This is obviously a simple one, but it's like the native resources you manage on a service, or sorry, you manage on a node, but these are service resources at the environment level. And here, what you're modeling is the interface that matters to that service. And this is primarily the machine information, but it could also be by way of the properties system. It could just be information that you care about that service. So for Postgres, you may care to add to it what extensions are installed, what versions here. That may matter to your application, or you just may want it so that you can query it out of PuppetDB. And so we have those resources modeled. We're going to have a number of these up on the Puppet Forge for you. You can export them here. And then when it comes to declaring an application instance, I'm going to take a look at that. Uncomment here. Make this a little bit bigger for you. So what's going on is we're declaring an instance, and just like anything else in Puppet, you can declare static resources, you can declare static classes. This is obviously a static example, but we're going to, this thing out of the box supports passing in data through Hiera, using your ENCs. We're going to add node manager support for declaring these. But the important part here is that I'm passing information through that you saw in my init. In fact, let me go ahead and split this to the right. Bring it out. Do a little zoom out. Okay. So again, we're just passing data through this system. And then here is the big trick here, the node assignment, because this application is just an idea. I might put it all on one machine. I might put it on my laptop for development, or I could spread it out. So the model's just meant to represent what are the possibilities. When you go to declare an application instance, that's where you make this assignment of PQL, API, and web onto Puppet nodes. And we're going to talk later today about where we're going with this. If you don't already have Puppet infrastructure connected, we'd like to provision that. We'd like you to say just how many you want. And here I'm just making an assignment. I'm going to go ahead and save that. Close that. And let's take a look. Oops, first I need to reset my environment cache. And to do this, I'm going to use the new orchestrator command line tool. And this is the primary mechanism by which you're going to drive change through infrastructure, and especially with distributed applications. So what I can do here is tell it the instance that I'd like to run in just standard resource reference syntax. I want a simple forge. And again, we've just assigned it to 3 different nodes. I'm going to put the model up so you can get a sense of context here. Did I edit the wrong site file? Downloads. I might have. Let me just do this live. Okay, whoopsies. Hunter would be ashamed that I'm not using any Vim tricks. Okay, so I've cleared my environment cache. I had that declaration. It just wasn't live on this box here. I'm connected back to Puppet Labs infrastructure. We've got a private data center running all of this. So I'm going to go ahead and run again with this Forge. And so what Puppet did here was create a plan from this model and how I've assigned it to infrastructure. It knew what components are in play. It knew what services are being exchanged between these components, and it built a run plan for that. And this plan, again, I'm not giving it a list of nodes to run. That's emerged from this environment level graph. And it knows I'm running my Postgres server first because I've created this relationship between these services that they depend on. I've got the API service going next, the web service coming after that. And what Puppet's doing then is kicking off Puppet runs. And as those runs are completing, we understand exactly when they complete. We're getting information back from PuppetDB. And we're doing this over a framework that the London team's been working on. Deepak's going to be on the stage tomorrow talking more about it, but it's the Puppet Communications Protocol. And that lets us have direct access to the Puppet agent. And it's still going through its same cycle. It's checking into the Puppet server. It's sending its facts. It's getting its catalog. But in addition to that, we know when is the run happening, is there one already in play, and then when it finishes, we can make a direct request for its report and produce some summaries. And this also sets us up to do more real-time feedback. As this is finishing, I'm going to show you the second piece of our demo here, where we're going to run a more complicated model. And this gets us closer to what I expect you're going to do with the orchestrator when you get your hands on it later this year. And this one just has same data that we passed through to it, except I've got two properties that changed, the count of APIs, the count of webs. We use some of the Puppet 4 DSL to just iterate over that and make the services that matter. And as we go through this, again, we're just using the Puppet 4 iteration syntax to say for every API that I requested, I'll make an API component, give it a name. I take that load balancer, and it's going to get in its APIs as the members. It's exporting an HTTP because the web is interacting with the API load balancer. And so we're going to make a number of webs that talk to the API load balancer, and then it itself is load balanced. Wah, wah. OK, there's different infrastructure underneath this. So I'm going to go back and uncheck that. Sorry, it's not very pretty. OK. I do have an example of that bigger over here. So what we did is just uncomment all of this. More nodes, obviously, but the same principle applies. And with this, you could patch it through in Hierodata. We're going to be doing a talk tomorrow about all the patterns you can use here. There's a lot of flexibility in this system. I'm going to go ahead and reset my environment cache, switch back, and hopefully I can do a Puppet job run on this. And one of the other things that we can do, I'm going to go ahead and zoom out here, is I can specify an application by its model instead of individual instance. If you've got a package update or a configuration file you want to apply to everything, not just that production instance or maybe a multiple, this will let you just do an operation on all of that. And again, this is just helping Puppet understand what's the target, what work am I doing on the infrastructure. And so I've got 7 components here. Again, it lays that all out. It tells me how many I'm running on. I've got tools like concurrency that's right now set to a default, but you can tweak. And so for each of these run stages, Puppet will give you a sense. Obviously, this is a little bit small, but in reality, you'd be able to say, I want 10 or more. We're going to have a sense of how canary hosts work here so that you could say, for that API tier, try one, make sure that all is successful, and then move on as quickly as you can to all the others in that particular tier. And again, Puppet's just going to kick off some runs. It's going to consume some information here. Oh, and while it does that, I might have talked too long here. One of the other features of this product is to be able to adapt to services that Puppet will say, hey, I kicked off this service, it's ready for work, but it's not actually ready for work yet. It's maybe loading 20 gigabytes worth of ads to serve. So it takes 20 minutes. You don't want Puppet to continue on to the service that depends on it and crash. So what this is simulating here is just that. I need to unblock the service here. I just kind of simulated that for you. The Forge is actually very responsive when it comes up. But what I want you to notice here is that it was making health checks, and those availability tests that it was making were based on the information in that service. I didn't have to hardwire any of that. It knew that there was a connection between these hosts, that Postgres server and the API servers. They were making requests, and that can be anything from a TCP check. In this case, it was a Postgres query. And if you notice, it blocked the configuration of any of those resources within my application component. So that health check succeeded, I moved on, and Puppet did all the work it needed. And these are based on health checks you may have seen on the Forge with the Puppet community team. And we're gonna have a number of them out of the box. You'll be able to create them yourselves. But for us, we just wanted to help you with all those applications that aren't resilient to failure. I wish all the applications we had to work with could just connect and retry, but we're not so lucky. So that's going to continue here, and as it does, I want to talk to you about a couple other features that I won't get a chance to show you. Another that Deepak will be on the stage tomorrow talking about that we refer to internally as direct Puppet, and that's really important to us. There's a couple things about what's happening here. These agents are running in a particular order. We may be running a particular tier as quickly as we can, but if Puppet's set in cron or just running in the background every 30 minutes, we don't want Puppet to just check in during this deployment out of order and break the whole flow. Maybe it checks in and it starts doing that availability test. The service isn't ready yet, so it fails, and then we move on. It's all misconfigured. And we don't want that to happen, but we don't want to sacrifice Puppet running in the background. That's one of the best features of Puppet. It checks in, it sends facts, makes updates to its configuration. It enforces the configuration it had and sends a report. If you do that in no-op mode in the background, you're getting that drift detection in play at a granular level and at a broad level. We don't want to sacrifice that, so with Direct Puppet, we're kind of merging these two worlds. Machines will check in and continue to enforce the configuration they have and continue to send all that rich reporting back to PuppetDB. But with the orchestrator, you'll enforce new configuration. Specifically here, all these configurations are new. And there's one more thing I want to show you that I think will make Direct Puppet's point here. I'm using the Puppet Classify Ruby library to the Puppet Enterprise Node Manager's API here to add some NTP configuration using the Puppet Labs NTP module. This just sets up time for Red Hat and Debian. And I did that because I want to show you one last thing the orchestrator can do. I can give it no argument. And one of the things you can pass in is the Puppet environment. But what it'll do is inspect the entire environment. What are all the applications I've declared? What instances are running? And if you notice here at the bottom, it also did a query for all the nodes that had been assigned or checked into the particular environment that I'm operating on. So now I have a little more nodes than my modeled applications enforcing new configuration. And when I'm configuring the machines that have relationships, Puppets were still respecting that. So we're still doing ordered configuration of the distributed applications, and we're kicking off as many Puppet runs as we can for the rest of the infrastructure to update NTP. And you can see a lot of these have just a couple of resources being changed. And so I think you're starting to get a hint here, or hopefully you are anyway, that there's a lot of different things this thing will do. There's a lot of different controls you're going to be able to pass into it. Another couple of examples here. The failure handling. When a node fails, what do? Do you care about any resource failure, or do you care about resource failures within that application component? And when it does fail, is one acceptable? Can I just take a failure and move on? All of those tunings are things you can assert to this orchestrator, and our design team is going to be excited to talk to you about what those combinations are. How do you want to express them? And we're going to build an engine for expressing those. And that's both the flexible controls, and it's also the more like RBAC. Who can operate on infrastructure? Can I give the application team responsibility of their application infrastructure, but they can only run Puppet in enforcement mode during their maintenance window? Or when they do it, they can't touch concurrency. It runs exactly as they do. And the failure handling options are up to you, right? Those kind of combinations are really important to us. I mentioned real-time feedback already. That's going to be pretty cool, and you'll also be able to tune, do I want to see every resource printed out? Do I want to see resources when things start to fail? When things fail, do I want to pause and then manually inspect it before the job continues? So we can have this pause and resume idea here. And what we're operating on, in case it hasn't become clear, is an environment level graph of all the nodes in your infrastructure, what application components they build, and how they relate to each other. And I think our infrastructure back has been a little bit slower than usual, but this was still a lot of nodes being run fast, and with Direct Puppet, it's going to be turned up to 11 here. Last night, this was down to 45 seconds. So I guess all of you are building machines back home. And that's going to be a quick look at what we've done here. But before I hand it back to Luke, I want to point out, if I could go back to the slides, please. Great. I could talk about the orchestrator all day, and good news, I will. So very soon here, I'm going to be talking with David Ludercourt. We're going to go over a little more overview, show you some things that I wasn't able to show you today out of time, and also talk about where this is going. Talk more about policies if you care about that. We're going to have a demo booth running from noon on, and the whole team's going to be popping through there and happy to talk to you about the orchestrator. Anybody with a Puppet shirt on is going to be happy to talk to you about the orchestrator. And at the demo showcase, you'll be able to take a look at something that I wasn't able to show you today, and that's the sort of thinking behind how, no matter what that application component is, how can we manage it? And so think about the F5 resources. Those are being managed to this remote API, but that's an application component, and the orchestrator can talk directly to that. So we're going to be talking about that, and if the application releases matter to you, if all those little operations you do, the state transitions, the symlink changes, the little operational tasks, this design jam that Eric Sorensen and the lead designers on the orchestrator, JD and Melinda, they're going to be going through that, and they're going to be really thrilled to talk to you. And Glenn Russell, an engineer on the orchestrator team, is going to talk tomorrow about making security a first-class concern through this concept of what services matter, how can we use the service information in the orchestrator to care more about security in our infrastructure. It's a timely topic. And also tomorrow, late afternoon, if you're interested on day one getting your hands on, David Ludercourt's going to walk through the language, and especially he's going to show you the patterns that we're building here to help you transition the code you write today to the orchestrator without modifying it. We have some compatibility layers in there just to translate your parameters. It's pretty slick. We really wanted to build this thing so that you could plug in any module you've written or what you've gotten from the Forge. And with that, I hope to see you soon. I want to turn it back to Luke. Thank you so much for spending time with me. Thank you, Luke.
Demo on stage.
Thank you. Thank you.
In front of what, 7,000 people? It's not so bad. So, I'm really excited about this product. We've been working on it literally for 4 years. At the very first PuppetConf, I remember walking around. It can't have been a piece of paper because I didn't print back then, but walking around showing people some of the early ideas that led to what Ryan just showed you. And there are two things that I'm really, really convinced about the orchestrator that he just showed you. First, I think it will help you on day one. I think for those of you who are using Puppet or who are thinking about using Puppet, it will be useful for you right now. It'll solve real problems in your infrastructure. I mean, like Ryan said, just making the convergence problem in distributed applications go away is a massive step. It'll be useful right now. And it's that first point of control and action at the heart of your data center, all built around the applications and infrastructure, all in context. I think it's really great. The second thing, though, is I'm really convinced that most of you are going to be incredibly angry about how much more there is to do on this product. We have a really compelling roadmap of opportunities, of things that we want to do. And some of you might be saying to yourself, things we should have already done. I don't know. But there's a ton of really great stuff. And I really think the orchestrator and the things we're working on for the orchestrator help to lay the groundwork for the next 10 years of what we're going to do, the next 10 years of where we're going to be pushing the product. I want to talk to you about some of our priorities, but I also know that you're going to have your own ideas. And one of the reasons that we pushed to get this product out without all the things that I'm going to talk about done is that, obviously, we think we're right. By definition, we believe our ideas are correct. But we want to give a chance for you to say, well, hey, here's an idea maybe you didn't think about. Or, I agree with your ideas, but maybe your priorities are wrong. Here's the thing that actually isn't as valuable as you think. Or, here's the thing that you really need to be putting up on the priority list. Because your feedback and how you use the product is absolutely critical to how this product is going to evolve. So we wanted to get it in your hands as quickly as possible and see what you can do with it. The goal of the orchestrator in the end is to be the spine of a modern application release infrastructure. And there are a number of things we're going to have to add to it to help it do that. First is it has to support the small transitions, the small orchestrations, not across the entire infrastructure, but little things like I have to drain the load balancer over here before I can restart the web server over here. Today, one of the things I think the orchestrator will make better, and actually in the next major release it should make better, is, Deepak I think is going to talk about, well, somebody at the conference is going to talk about Direct Puppet. And Orchestrator plus Direct Puppet is going to make it much easier to build Canary hosts and to use Canary hosts. Today, if you're using Canary hosts, you have to take a host, pull it out of the environment it's in, push code to that new environment, test it there, put it back in. With the orchestrator, you'll be able to do gradual deployment of new code across your entire environment without having to pull machines out of the environment. And not just that, you'll be able to take those deployments, take that work you're doing, and save that. So, hey, I want to deploy to this machine, and then 3 machines, and then 10 machines, and gradually increase the deployment. You'll be able to build those policies, and then save those policies, and make it so other people can run them for you. So if you've got a team, you can have some people who are building this is how I deploy this application, and then anybody in the organization can come and hit the button to deploy, and you can know that it's going to follow this automated, gradual workflow process. We also know that rich feedback is critical. Just handling error management is a big part of successfully doing deployment. So we've got to have great human-readable output, because obviously a tool that is only useful for computers is not that useful. But we've also got to have really good machine-readable output. We've got to have tools that you can build tools to talk to, whether it's directly to our API or the CLI, so that you can parse that information and integrate it into your systems. One of the strengths of Puppet has always been, if you've got information that you need to use in your configurations, we want to make it easy to import that data into our world. Similarly, if we've got data that you would find useful in something you do, we want to make it easy for you to get that data. And the orchestrator has to do just as well at that, especially in a lot of ways it gets more complicated, because obviously we're dealing with distributed applications here. The orchestrator also becomes the integration point for a lot of these new workloads that are going to run alongside your existing infrastructure. Whether you're using containers like a package or a service, or you're treating containers like virtual machines that are just thinner and lighter, you'll be able to integrate those containers into the orchestrator and not have to say, well, I've got a new world over here and an old world over here, and we don't really know how to integrate them. Because the reality is, in a lot of cases, your web front ends might be your containers. But as Ryan said, if you want to run a microservices architecture for your web application, but it's using mainframe data, you aren't going to containerize that mainframe anytime soon. And we can even integrate with services like Kubernetes and Mesosphere, all while being great at managing your traditional workloads. So that ability to say yes to whatever it is, that ability to manage whatever you've got directly, is a huge part of what's going to make the orchestrator great for you. Puppet grew up in a world of servers, right? The way that I started and the early days of our efforts were all about servers. And in the world of servers, agents are obvious. It makes sense to install software where it's easy to do so. But in the last few years, really longer than that now, we've also invested heavily in environments where it doesn't make sense to install an agent, or you can't. Places like an F5 load balancer or a NetApp device, technically you could install an agent on those, but people really want to treat them like appliances. I don't want to have additional software on there. I want to manage it via the API. Or a Cisco iOS device. You just can't install an agent on that. There's nothing you can do. But even more so, what about AWS? There's no way, I don't think they're going to let me install an agent in Amazon, but what would it even mean? Right? That doesn't make any sense. It's a platform. It's an API. We've got support for managing all these right now, for interacting with all these. And what the orchestrator allows us to do is to promote all that support into being first-class citizens. A lot of these should only exist at the environment level. Right? When you've got one host managing another host, that doesn't make nearly as much sense as saying all of your hosts exist in the environment. All of your platforms are directly plugged in to the core of the environment. And it doesn't matter whether that host is a container or a virtual machine or a physical machine or a transient machine on the internet somewhere. all of those have a home for the first time. And all of this plays into our strengths at saying yes. Heterogeneity has been a core strength of Puppet and a core tenet of Puppet since the very beginning. We know you don't have the luxury of getting rid of old stuff just because you bought new stuff. We know that you don't have the luxury of saying to your users, to the people who actually are building the applications and managing the applications, I'm sorry, no, you can't bring anything new in, or you can't bring that new stuff in until I can get rid of the old stuff, right? I'm sure none of you are still running Red Hat 4 anymore, obviously, but there are some people out there who are running old technology. There are people who have to support everything. And my goal is, if it has an IP address, I want to manage it. If you're not embarrassed to admit that you run it, or frankly, if you are embarrassed to admit that you run it, I want to manage it. Because we're never going to be in a homogeneous world. We're never going to be in a world where everything looks the same. We're never going to be in a purely OpenStack world, or a purely VMware world, or a purely Docker world, or a purely Amazon world. It's not going to happen. We will forever, for better or worse, have complex, heterogeneous infrastructure, and you need to have tooling that supports that. This orchestrator is a critical step in that journey for us and for you. The orchestrator is just one of the great things we're working on, though. Tomorrow on this stage, Deepak will discuss a lot of the great technologies that we're working on, some of which will ship very soon, some of which, maybe you never see them, I don't know. I can guarantee you that we as a company are going to be pushing through a lot of changes in the tools we have and the tools we're building. Changing is incredibly important for us. We have a choice. We can be great at Puppet, and Puppet is great technology. We can be great at taking Puppet and getting the absolute most out of it, building the broadest adoption, the widest support, the most usage. But I really think we need to be more than that. We need to be great at solving your problems. And some significant part of solving your problems is going to involve Puppet for a long time. But there's a lot more to it than that. Growing up, I used to do carpentry. I would do remodeling with my father. And if he had thought of himself as a person who hammers, then for most of his career, that would have been just fine. Although, of course, he also did painting and sanding and lots of other things. Painting is the worst. But when the pneumatic nailers came out, suddenly you're spending dramatically less time hammering. In many cases, you don't do any hammering, right? And the amount of time you spend doing the thing that hammering used to do is much less. So if you are a person who hammers, pneumatic nailers are catastrophic. But hey, if you're a person who drives spikes of metal into wood, you're now way better at your job suddenly, right? That's pretty good. Significant tool upgrade made you much better. But what about the world where you buy pre-built frames that allow you to build entire houses incredibly quickly? And these houses are cheaper, they're better, and they're more durable. Now you're being a person who drives spikes into wood isn't valuable at all. It was critical for my father to know that his job wasn't to hammer, it wasn't to do anything involving that. His job was to build houses for people. It was more than that, though, actually, because it's not just about houses. His job was to build a home for people, a place where people wanted to be, a place where people could live and really loved being. And that meant that as the tools changed, as the details on the ground changed, he didn't have to change that much. Yeah, you got to learn some skills. Maybe don't bring 5 hammers to work. You only need 1 now. But it allowed him to stay relevant as the world changed. I know this change is disruptive. I know the change isn't usually very fun. And we as an organization have to balance the rate of change with the cost of change. A lot of times I get people come to me and saying, hey, our users don't want us to release as often as we do. We need to stop releasing. We need to slow things down because it's making people uncomfortable. And the natural response to that situation is exactly that. Oh, well, let's release less often. Let's find a way to package more things in, stuff like that. But I think that's the wrong way to look at it. That's the wrong way to balance rate of change and cost of change. What we're going to do is, instead of reducing our rate of change, we're going to reduce the cost of change. I want to make change free for you. And that way we can change as often as you want, you can change as often as you want, and you don't have to worry about it. The cost of updating your agents should be 0. For those situations where you're running an agent, you shouldn't have to think about it. The reason we built the all-in-one agent isn't because we have this crazy megalomaniacal view of how you should install software in your client. It's because we don't think you should think about it. We don't think the agent should matter to you all. It just shouldn't show up in any part of your thinking. It should be irrelevant. And that's the goal with the all-in-one agent, is to make it so you just don't have to think about it. The cost of updating your infrastructure should be as close to zero as possible. And I don't think we're ever going to get it to zero because things are complex. But we should do everything we can to make it so you can cheaply and safely update your infrastructure. As just one example, we recently released the catalog preview tool that allows you to quickly confirm compatibility between releases. So if you're looking at a new version of Puppet and an old version of Puppet, you can quickly confirm for a given host whether the new configuration is going to have the same output as the old configuration. Using a preview tool a lot like this, we were able to upgrade more than 10,000 machines a day with a customer. And over the course of a week, we upgraded 64,000 servers. That's a pretty low cost of change in my world. So we know we have to drive down this cost of change. And we know that for you to give us permission to make as many changes as we want to make, the changes have to be fast, they have to be cheap, and they have to be safe. So that you can do it frequently, cheaply, reliably, and with low risk. This is a significant departure for enterprise software. When Chrome first did something like this for browsers, it was a pretty big departure for consumer software. I know it was the first thing I installed where it didn't say, oh, well, should I check for things, and I'm going to give you dialogues and things like that. You just literally had to stop thinking about it. It never came up. Once in a while, you would get a little red bar that says, hey, you should restart your browser. But that was the extent of it. That was a pretty big change. I bet there are still IT departments today that theoretically prohibit you from running Chrome because it can't go through the update cycle. And yet, even with that, it's got 64% browser share. And I know it's not just because it's ridiculously easy to update and maintain, but I bet that's part of it. You always get the latest thing, and you never have to think about it. And it works pretty darn well. So because of things like Chrome, because of things like your iPhone, I mean, remember how horrible it was to have to go into the App Store on your iPhone and actually manually click Update? Right? And compared to normal software updates, clicking a button is pretty fantastic. But compared to not doing anything at all, clicking a button is horrible. It just made no sense. And when they finally made it so you didn't have to click the button anymore, it's like, oh, finally. So your expectations have changed. What you want and expect from your software has changed. Consumerization of IT is usually talked about as bringing your own devices. And actually, it's also talked about like it's new, but the reality is the original PCs were also prohibited from being brought into organizations by IT because they owned the only two computers that company needed. And people would bring them in anyway, and eventually, when the execs wanted them, suddenly IT goes, fine, you can bring in your computers. So bring your own device has been around for a long time, but it's not just about the devices. And I would say actually today, it's not even primarily about devices. It's about the consumer-like experiences that you can get in this consumer world. You expect software that's easy to install, easy to understand, easy to use. And this is going to sound crazy, but actually easy to explain to other people how to use. Better design of the software you use contributes to your success. And I assume all of us have used enterprise software that is horrible, that is just embarrassing. But just as one example, I know a company that their sales got to a certain point and it started to flag. And so they started to try to figure out what happened. How did this happen? How did our growth rates go down? And so they did some analysis. They actually took a really daring step of watching their users try to use their software. And they discovered that one of the core workflows, one of the primary reasons why people bought their product, required 80 clicks from beginning to end to accomplish the main task. And even better, if there was an error or a failure somewhere in that process, the vast majority of times, they had to start all the way in the beginning again. That's insane. And the only way you could ever be in that world is if no users were ever involved in the creation or purchasing of that software, right? And that's the typical enterprise software user experience. It was a golf-mediated purchase or something like that. But the world has changed. Now you know to blame the designer when you can't use the software. It's not that you're stupid. It's that the designer doesn't know what you're trying to do. It doesn't know why you hired the software in the first place. And now you do expect Apple-like usability, even for internal apps, right? Even if for apps that only have 3 users, you still go, why is this hard to use? It doesn't make any sense. All of this, while the software world itself is getting more complex and more critical every day, right? If it was just getting more complex and we can kind of shove it off in a corner, that would be fine. But as Ryan said, so much more of what we do on a daily basis is mediated by software. I mean, the Volkswagen scandal, right? Like, that's software. You couldn't really fake that with hardware, but it was actually pretty easy with software. It feels like we're building towards this inflection point, like tomorrow or next week or in a year, something crazy is going to happen. It's not. We're in a sustained high rate of change for decades. Today feels crazy. In 5 years, it's going to feel crazy. In 15 years, it's going to feel crazy. It's going to continue to feel this crazy for a really long time. Because we still really have a long way to go. As I was talking to somebody earlier, I mentioned earlier that, one way of talking about the world we want to be in is that most of the software isn't horrible software. Just think about the software stack that you normally have to deal with and ask yourself, how much will our industry have to change before the majority of the software that I have to deal with is good software? Right? It's a long ways away. Gartner says that in our industry, less than 15% of the market uses any kind of automation. The biggest conferences in our world, well, how many people are at this conference? I think we're actually the biggest conference in the world that we live in. But compare that to VMworld. We're 1/15 the size of VMworld. We're 1/100th the size of Dreamforce. We have a long way to go for that kind of relevance, that kind of reach, and that kind of impact. And this doesn't frighten me. To me, this inspires me. This says, we've done so much, but there's so much more opportunity. There's so many great things we can do. And our movement right now, the things that we're trying to do, the technology we're building, the changes we're trying to make, that movement is at its most vulnerable point. We're large enough, and we're visible enough, and we're popular enough to think that we've arrived. But we're not, right? We've just gotten the right to go do the interesting stuff. For all the work we've done today has gotten us to the point where we can now try for the big field. When I got to college, I'd spent most of my life in school focusing on leaving my hometown. And I knew I wouldn't survive in the military, so I figured I had to get good grades, and that getting good enough grades, I could go to a school that was anywhere other than where I lived. And I got to school, and I was like, I did it. I won. And it turns out that they still expect you to go to school when you get to school, and you have to do homework, and you have to take tests. And it was really frustrating, because I just wanted to play pool. So, and actually there's a related thing. Everyone asks me, hey Luke, what's Puppet Labs' exit strategy? As though, let's say we were going to IPO, you can turn in all your shares for cash and you get to go home. No, you got to go to work the next day too. There's so much more to do. And I need you, I need the people in this audience, I need the people watching this stream to enlist in that next 10 years. Because I know the last 10 years was interesting, it was fun, it was challenging, it was creative, it was inventive and innovative. But I think the next 10 years is going to be so much more interesting, so much more challenging, and so much more valuable that I want you all there with me. And you are in the best position to lead. You've already proved it. You've already helped build the most widely used configuration management system in the world. You've already proved that you understand what it takes. You've got a vibrant, accepting community. One of the things I love best about the Puppet community is how well we treat new people. I've been part of so many communities that look down on people who aren't already members of the community. And a big part of how we've grown is being, and this is going to sound crazy, just nice to people. You care about the technology and you work to improve it. So it's that combination of community and technology that really helps you succeed. As just one example, a team of 37 people recently, including Felix Frank and Igor Galek, adopted a bunch of orphan modules in the Forge and gave them a home under the Puppet community GitHub team. And they've been working autonomously to get these modules well maintained and up to high quality. And you can see their work today at puppet.community. And no, that's not a typo. Community is a top-level domain. I have no idea why, but it is. So go check it out, maybe after the talk. These efforts, and all of your efforts, are critical to the success of automation in the enterprise and around the entire industry. You've made more impact on adoption of automation in the industry already than anybody else. Because you're at the center. You understand the real complexities. You know that there's no future with fewer servers, fewer services that are less complex or less critical. And with this awareness of these complexities, you're best suited to help turn over the software supply chain, to help make all of those individual pieces change, to rewrite how we build software, to focus on the customer experience. I need you to be prepared. The next decade is going to require something different from you. Most of you are sysadmins right now. Most of you are administrators of some kind. But you will need to be great at thinking of the entire stack. You'll need to start moving from the individual pieces to thinking about the entire application, to asking yourself, what is the real problem? What is the problem my customer is trying to solve? I have a customer who's been working at a bank for a long time, and he's been managing, for the last 3 to 4 years that I've known him, the server and cloud teams. And he just moved over to manage the network teams. And the first question he asks his network teams is, what are the applications that are running on your network? And how are you building your network to tune them? And they said, oh, well, those don't matter to us. We're just the network people. And I expect he's having very uncomfortable conversations with them right now, because he realizes that for them to succeed, for them to do their job, for them to provide great software to their customers, every part of the chain has to understand how their work supports the value they're delivering, supports the customer experience. So as you make that shift from worrying about the individual pieces to managing the entire application, you need to think about how tying all that work together helps align with the application you're building, the user you're building it for, and how it all delivers value. And you need to help make that change from artisanal operations to fully automated infrastructure. The future is very bright, and I look forward to being there with all of you. Thank you.